We talked about odd multiplicities on Friday, and you just did some today. An odd multiplicity gives you what type of x-intercept on the graph? Sorry? Yeah, but what is the multiplicity? What does an odd degree multiplicity cause to happen on the graph? It's the through, but it flattens out. It's the point of inflection, right? Point of inflection, the POI. POI. All right? It's those things that look like this, come up, and they sort of flatten out. Technically, it changes the concavity of the graph. We're not worried too much about that. We deal with that in calculus. Okay, so what do you think happens if the odd multiplicity increases? Like if we go from 3 to 5 to 7, what do you think happens? What? It would just rise faster. That's all that happens. Well, the flat part's the same. So these all have x-intercepts of 2. But if I did the y-intercept here, that's when x is 0. That's going to be negative 2 cubed, which is negative 8. What do these go up by? 10, 20, 30, 40, 50. So negative 8, say, is right there. So the graph looks like that. That's x minus 2 cubed. If you change it to the power of 5, it's still a point of inflection at the same x-intercept of 2, but it's negative 2 to the 5th, which is negative 32. So you can see there's negative 32. Now the graph is rising and falling faster. These are really bad graphs, but let's see yours. X minus 2 to the 5th. And what do you think happens to the 7th power? It's just more vertical, right? That's all. I'm not going to draw it. The whole point... Well, apparently I draw bad graphs. Well, I love your graphs personally, so I think we should have... You want to come up and do it? Yeah, I want you. All right. So it's just going to get steeper. Steeper. That's all that happens. What do you think if it's an even multiplicity? What do you think is going to happen? It's going to be the same thing, but it's going to be a steeper bounce. That's it. Okay, so if we did y-intercepts for all these, we get negative 2 to the 4, which is, or negative 2 to the 2, which is 4. Negative 2 to the 4, which is 16. So these are horrendous parabolas. That's x minus 2 to the power of 4, to the power of 2. If you change it, general shape is the same. They just get steeper as the degree goes up. That's it. Okay? The shape of it doesn't change in terms of it's a bounce or it's a point of inflection. And to be honest, what you can represent when you're sketching a graph is you can't really represent this. Okay? But just so you know, as the degree increase or as the multiplicity increases, you just get a steeper graph. That's it. Okay? That's all I need you to know. Next page, please. All right. Let's look at these 4 graphs here. So unless I state the degree of a graph, you always assume it's the lowest possible degree graph. Okay? So if you have a point of inflection, assume it's degree 3. If you have a tangent, assume it's degree 2 or multiplicity of 2. Okay? So taking that into account, of these 4 graphs, which one could be a polynomial of degree 8? There's a couple ways to do this. Anybody? One? Which one could be a degree 8 graph?
1, 2, 3. Not 3, Jack.
Okay, can 1 be degree 8? If it's an even degree polynomial, what do both arms need to be doing? They go in the same direction, right? So the only one that works is 2. And the other way you can think about that is, if I look at it, if you pass straight through, that has a multiplicity of 1. If you bounce, you have an even multiplicity. So if that's a multiplicity of 1, that's a multiplicity of 1. This has to have a multiplicity of 6 to get an 8th degree polynomial, right? So then the degree would be 8. Whereas if you did like this one here, 4, multiplicity of 1, multiplicity of 1. How do I make this? So we need 6 more. We need a multiplicity of 6, right? But can this be a multiplicity of 6? No, because it's a point of inflection, right? It's not a bounce. So it's either going to be a 3, a 5, or a 7. So it's not going to work out. Okay. All right. Which of the graphs has a leading coefficient that is positive? So how do you tell if the leading coefficient is positive? The right arm should be up. So it has to be 2 or 3 or 4. Okay. So 3 and 4. Is that okay? This is just kind of testing your confidence with degrees and what the shape of the graph. Okay, can you make a rough sketch of this graph?
I could try.
Well, let's do it together first. What's the degree? Not 4. It's not 5. Oh, did you say 6? Oh, sorry. Degree is 6. That's right, because x1 and that's 1, so we get 6. What's the leading coefficient? Negative. So if the degree is 6 and the leading coefficient is negative, what are the arms doing? They're both down. Mark out your zeros. If you just have an x, what's your x-intercept? So it's right at the origin. 1 and 4. Both arms have to be down. I always start in the left. We come up. What happens at the origin? Right through. At 1, we get a bounce because it's even. And at 4, we pass through again. Again, I don't care how high the bumps go because that's more of a calculus problem, so we're not going to worry too much about that. Okay. Is that okay? Yeah? State the degree of these polynomial functions. We are assuming its lowest possible degree. So the first one, what would the degree of this function be? If you bounce here at A, what is that multiplicity? 2. What about when you pass through? 1 and 1. So what's the degree? Okay, is the leading coefficient positive or negative? Why? They're both down. What's the degree of the next one? 6, because that has to be 3, and that has to be 3, so the degree is 6. Leading coefficient of positive. All right. Last questions for this lesson. So you're going to get a question like, sorry.
So this is like the other one, like for example, extreme value on that, so we don't take that into know what those functions like this is not that we get to access.
Yeah, all I want is the x-intercepts. That's what gives you the, yeah. Okay. you will have a question like this. So I will give you a bunch of information about the graph. You should be able to sketch the graph. All right. And you'll see in the next lesson, generate an equation. So we have a positive leading coefficient. We have a real zero. Okay. Basically, that just means it's not an imaginary one. It actually hits the x-axis. Okay. We're not going to talk about the imaginary ones that don't hit the x-axis. So you have a 0 or an x-intercept of multiplicity 1. Now, they haven't told us what the x-intercepts are, so you can make them up. I'm just going to call them A, B, C, D. Okay. So if we have a real 0 of multiplicity 1, that essentially means we have an x minus a to the power of 1. We have 2 real zeros of multiplicity 2. So that means you have like an x minus b squared and an x minus c squared. And we have 1 real 0 of multiplicity 5. Let's call it d. So if you wanted to write it out, you could say it's positive leading coefficient. You can make it positive a. It doesn't really matter because they haven't told us where they need to be. There we go. So what is the degree of this polynomial function? 10, right? Does everybody agree with that? Just add the multiplicities. 5 plus 2 is 7, 9, 10. Leading coefficient is positive. So both arms need to be up. Mark your A, B, C, D. I usually just move left to right. I would just put an equal number on either side. It doesn't matter where you put them. On the test, I'll actually give you numbers. Okay, so it's a little more clear. So degree 10, positive leading coefficient. So both arms need to be up. Start on the left, come down. What happens at A? What happens at B? What happens at C? And D? POI. And just if you want to emphasize the POI, just write POI right beside it with an arrow or something. Now, what should I do to technically make this correct, I guess?
Find the y-intercept?
Well, we can't really find the y-intercept because it's just letters. I should make that plus and that plus, right? The A's and the B's should technically be plus because they're on the left-hand side, but or I could write negative A. I mean, I don't really care. I'm going to give you numbers on the actual assignment. All right. Are there any questions about that? I'm not doing the next one because it's exactly the same thing. Are we okay? It's debatable. Nobody is. 3, 4, 5. 3, 4, 5, please. And that will be the end of this lesson. And we'll get on to the last lesson of the unit.